live, and then I should see us live shortly here. I think we're actually live now. So with that, hello everyone, and welcome to another Nomad HashiCorp. Oh wow, I hear myself. We're live. Anyway, welcome to another Nomad Community Office Hours. I can hear myself again somewhere. What is this? Now we've got to be good. If you've ever tried speaking when you can hear yourself, it's very difficult. So third time's the charm. Welcome to another Nomad Community Office Hours. And today I've got James, Louise, and Jasmine on. We're going to be talking about GitHub issues and triaging and going through some like real world examples of ones that we've ran into and what kind of made them good or bad or like great or just difficult to work with. And we'll have some tips for contributing as well. Just before we get into introductions though, just wanted to remind you that we do have a code of conduct over at hashicorp.com/community-guidelines. And you can take a look at it there. But in general, if you're looking to talk with us today and interact with community, we just ask that you be welcoming, inclusive, friendly, and patient, and considerate, respectful, and professional. And with that, Louise, would you like to introduce yourself?
Sure. Hi, everyone. My name is Louise, and I'm an engineer in the Nomad team. James?
Hi, I'm James. I'm an engineer on the Nomad team.
Hey, I'm Jasmine. I'm an engineer on the Nomad team.
I see that I should have given another prompt, but that's okay. Yeah, I guess, Louise, would you want to get started? I know you prepared some tips to share with the audience, and maybe we can kind of walk through some of those tips and do a bit of a discussion about each of them if there's anything anyone else would like to contribute as we're going. So that's kind of our plans. We're going to go through some tips contributing today, and then we're going to go through some of the actual examples. So would you like to get us started with the first tip you had?
Sure. Yeah. Like as usual, contributing to open source is always kind of scary. Like it's very hard to know where to get started. And then once you do get started, it's hard to like keep track of what's going on. So based on like some of the experiences we had as maintainers, I come up with some like tips to help you go through the process and like monitor progress and things like that. So I think the first tip that I have is to open the issue first. A lot of times, you might be eager to just jump in straight into code and fix something and maybe contribute like this huge PR that does some really cool thing, but maybe it's not something that we're ready to accept or something that we have a solution in the work or something already planned. So if you jump straight into code, you might waste time and effort trying to come up with a solution that may not be the best. So the first tip is to first open the issue and have a discussion with us. That way we can guide you through a solution that fits the project better, because it's very hard. Like Nomad is a very big project. So it's very hard to know exactly what's going on. And then we're also not the best at keeping a public roadmap, I should say. So like it's very hard for you to know what's coming down the pipeline. So open the issue first. If you have a nice idea, we have a issue template for feature requests. So open that, put as many thoughts and details as you can there, and then we can have a discussion about how to best implement the feature that you're looking for. So that's tip number one. Tip number two is to always add reproduction steps. So whenever possible, at least. That helps a lot when we're triaging issues. If there are like steps that we can just follow without thinking too much, that always helps, because then it's less effort for us to reproduce the issue and to analyze it deeper. So always try to find a way to reproduce your issue. Bonus points if you can provide like the minimum reproduction steps. I know that's like extremely hard to do. Sometimes you do like a lot of sequence of steps and you don't know which one exactly caused the problem. But try to reproduce and then try to skim away as many steps as possible to like get the minimum reproduction steps, and also the minimum reproduction job as well. That would be helpful. So like, you might have like console connect, but maybe the issue is not related to console connect. So maybe try to remove that. So try to reduce your job file to the minimum issue that gets caused. That helps a lot when we're reproducing and studying the issue. Next thing is to...
I think was like, let's pause on number 1 and 2, because I was curious if James or Jasmine had anything else to share around those tips.
Well, around tip 1 for filing the issue, I was going to say the most important part is the reproduction steps. And then Luis went to tip 2. So also don't beat yourself up if you include stuff that you thought was relevant and then you find out later. That's burned us before as well. Like spurious log messages during leader election, it's hard to tell. So
Yeah, being overly verbose, I would say, is not a bad thing. Particularly, you know, if it's a bug, then that can just help us. We can easily, you know, it's our job to maybe filter out the things that aren't relevant, but it can create a bit more of a feedback loop and a bit more time if we have to ask for particular information. That being said, it's a balancing act, verbosity versus too much information. But if you're not sure whether to include a piece of information, just put it in there. It's always useful.
Cool. Yep. And then next, when you're submitting the PR, you know, you have the discussion with us. We talked about the solution. Now it's time to code. Nomad is a very large code base, so don't be afraid to like ask more detailed questions, or like, you know, which file should I change, or things like that. We can go into like more specific details with you and help you there. Also, when you're submitting the PR, try to keep the PR very focused on what you're trying to solve. I know that, you know, when you're deep down into the code, you might find other things that you might want to change, but that's usually not a great idea for a PR, because when you're reviewing, we're associating the PR with an issue. So if you see things that are not directly related to the PR, it's kind of confusing to review that without that context. So, you know, try to fight the urge of like changing other things and keep focus on the issue itself. Tests, it's hard to write tests, but we very much appreciate when people try. If you don't know how to write those tests and don't know how the Nomad test suite works, that's okay. I don't know much of it myself, to be honest. The end-to-end test to me is still a mystery, but no worry, like just ask us the question and we can help you write those tests as well. What kind of test cases you need to write, which files to change, these kind of things. We can help you with that as well. And then just general like code formatting and things like that, making sure your HCL files are formatted, your Go files are formatted. Those little details, it takes some time because like takes a back forward, like, oh, we should format this file. And it's kind of annoying to ask all the time. So try to look at those while you're reviewing your own PR. So I think that's kind of the next step. It's like when you open the PR, look at the files changed and like pretend that you don't know what changed, and try to look at over your own changes and try to catch like small things that you could improve.
Actually, I have a question around that too. Oh, but James, go first.
No,
Sorry.
I was going to say that that's a good point. I do that more by accident when I see my code, like, oh yeah. But taking that second review is, I personally find it a really useful way, and I review it before I press the raise PR button on my own stuff, because there's always something I've missed, like a debug line or something that can sneak its way in.
Louise, it might be worth, when you screen share later, just showing where the contributing documentation is for remembering all of those things that you should include for a PR for tests and stuff.
Yeah, that would be great. And we can drop the link in chat too, so that people can check it out on their own if they're interested too. You mentioned a bit about kind of formatting and trying to make sure you do it. Do you have any kind of tools or extensions that you find helpful for checking this as you're doing that yourself? This is an open question, but yeah.
Several. So that's the problem I said. Like I use Vim and a bunch of plugins, but I've been kind of like accumulating them to the point where I don't exactly know which one does which, but there is a HCL FMT tool that does HCL formatting. And I want to say that I use the Terraform language server to call that and format on save, but I might be wrong. And then there's the same with Go. I think it's called Go FMT that will format your source files. And I always make sure that I have those trigger on save. I think on VS Code is like a JSON file, settings.json, that I need to add it. Vim is kind of mysterious because I think each does its own thing. On Golang, I think there's also a checkbox that you can set on your IDE. And another thing that it's helpful, I don't think we do it actually, it's a tool called editor config. I don't remember if we have one now, because I don't think we have, but I have one on my home directory. So editor config is like a tool that automatically configures your editor for things like adding a new blank line at the end, or ending with a line feed instead of the carry return and things like that. You would do automatically for you. So I think those are the tools that I use for formatting and making sure they run on save. I think that's the most important thing.
Yeah, and something I found more recently, I use a lot more. There's a Vagrant machine in the root of the Nomad repo, and so I use that a lot because it installs kind of some of our basic tools like HCL format and some of the linting tools. So if you're unsure of kind of how your local machine's set up, or it can be a hassle to make sure that you match, go ahead and use that. That brings everything in, so you can run the make targets without worrying about it.
Yeah, if you're doing Nomad development on Mac OS, you will need to use the Vagrant machine. For the rest of us on Linux, it's the Wild West.
Sorry, that kind of got me. Okay, I'm done dying now. But was there any other tips that you wanted to share? Now I've lost where we were in the doc, but
yeah, two more. So first one is sorry for the delay. That's more like not really a tip, but just apologizing ahead. We get a lot of issues and PRs to look over. It might take a while to get to your issue. It's not ideal and it's frustrating, but it's kind of hard to manage all the incoming work. So please don't be angry, but also feel free to ping us if it's been a while. You don't get mad, but just don't ping us every day. And the last tip is just for looking for ways to help. We talk a lot about coding changes, but that's not always how you can contribute. If you don't have experience to go or just getting started with programming, there are lots of ways that you can help. Documentation is probably the biggest one. There's always room to improve our docs. So if you find anything, even just a typo, it's always nice to have those submitted and contribute to us. We do read our own docs, but sometimes you kind of just memorize some stuff and just gloss over errors. So any type of contribution there is helpful. We do have a label called Good First Issue that we need to use more, but we sometimes use it. So that's probably another, when you look at the issues, you can filter by that label. So those are usually small fixes that should be fairly straightforward to get started. That's a good place to look. Other thing that you can do to help is looking at the issues themselves, look for new issues that other people open, try to reproduce them. If there are no reproduction steps, try to validate and just hey, I tried this as well. It's always nice to have some sort of confirmation that this is a more widespread issue, not an environment specific issue. So those type of things are always super helpful as well.
Yeah, I think we got some tips in chat too around, I think Dave contributed that when he's working directly on macOS, he uses VS Code, and that there's, I think there's Jasmine's point previously about Linux, that there's some things that can only be tested there, but it still tends to work pretty well. We did get a question asking if it's okay to tag specific people in the GitHub issue, or if it's better to just kind of leave it and let us get to it.
I can take that. I did comment in Slack. We actually have a triage process. So we do a rotation, a weekly rotation, where one person is generally assigned to handle the initial triage. So ideally, I don't know how Louise, Jasmine, you feel. Ideally, not pinging specific people when you open it and letting that triage process happen, because it's actually a nice process to learn different systems of Nomad if you're kind of poking around in triaging an issue. It also means that maybe the person that might end up doing that work is kind of able to focus on some implementation work whilst they're not on community rotation. So my preference would be to not ping and let the process take its toll. But that's my opinion.
Please don't at me. Unless I'm assigned, then maybe that's okay.
I guess a follow-up, if no one actually responds, like within a couple of weeks or a week, then yeah, I'll give you permission to at me. That's fine. I might not get round to it, but so what happens sometimes in that situation, we might not respond straight away, but it can raise attention, and we'll discuss it like in an internal team meeting. So that's okay. It's just, as Louise has alluded to, there's a fair amount of things that come in, and some of them are tricky and take a while, and that can sometimes mean that we miss maybe the simpler things to respond to.
I'm curious, what does the triage process look like? If we can talk about that a little bit. If you're fine with that.
No, I'm trying to remember what I do. So it focuses mostly on the issue queue. We don't really have a formal process for PRs because PRs require a bit more context around understanding the change and the risk involved. PRs kind of also relate to what stage of development we're in, whether we're in a patch release or a feature release. Typically, we try and time box looking in at each particular issue. That might change if it's a panic or if it looks like a serious problem. And then, case in point, Louise was looking at something yesterday, which I believe took up pretty much the whole day. But that's because it looked like a more serious thing we should address. But typically, we'll time box it, try and understand the problem, see if we can reproduce it if there's a bug. And then you'll see it kind of, we have a community triage board, which I don't know if non-members can see. Maybe someone can clarify in chat. And we move it across from triaging in progress to done. If it's a small fix, maybe like a documentation problem, or it's something really obvious that we can do within, for me, probably half an hour, then I'll try and raise a PR. Otherwise, we'll try and respond, give some feedback, or ask some more questions. And then generally, it will go into a road mapping queue, where then the Nomad leadership team they meet, I think, weekly or bi-weekly to try and process that and come up with our priorities to try and fix. Some take longer to triage. The ones that are interesting, sometimes you might spend a few hours digging in. But that's kind of, I think, how it works.
I would also say that for the PRs and the more technical parts, we do have a lot of discussion internally in our daily stand-up or like syncs where we may do group code review or just generally discuss design, or like yesterday or today talking about the potential PR coming in from the community.
That's probably one of the biggest shocks for me coming from community to internal was the level of discussion that you don't see externally that goes on around even the smallest kind of ticket or PR. Like it's interesting how much discussion can happen. We have, you know, daily meetings to discuss ad hoc things. So your issue might generate quite a lot of internal discussion, no matter how small it is.
And I think today we're going to do a little bit of that triaging live. Luis, are you ready to take it away into that?
Yeah, you can take it. Is that triaging specific? It's just I picked some issues that were like interesting during triage, so they already been triaged, but we were going to walk through like kind of the process that went through during triaging. So let me share my screen. We can get started. So the first issue is this one. So this is an issue about Nomad plan. And for those who are not familiarized with Nomad specifically, but you might have seen that in Terraform, when you have a job running, you can do a job plan, and that will tell you the diff between the version that you have running versus the new version that you want to run. So firstly, going over the issue here, it was a very nice issue because it followed like the tips that I mentioned before. So the author here opened the issue first, provide very nice reproduction steps on how to reproduce the issue, just to like explain to us what the problem was. And yeah, so kind of going back and looking at this as a maintainer, or like a Nomad maintainer, the first thing I would do is just follow the reproduction steps. So looking at, for example, the Nomad version that they're running. So I will start Nomad 112, 112, 112, because like that's the version they're running. So always good to point out which version you're running, so we know which version to test and to validate. And then I have the job also copied here. So basically copied over the code. Now I did remove some things like console connect and like the bridge mode, because those are like specific to Linux, and I don't feel like bringing up a VM alongside Zoom and alongside all the other tooling. So like since those are not important for this test, I just removed those, but the rest I kind of kept the same, and I forgot to comment this block again. So let's, following the reproduction steps, let's deploy this job.
Also, nice work on doing minimum viable repro.
Oh yeah, that was a nice like self-contained job. I just had to remove the connect, so that was pretty nice. So now I have the job running, and then the next step is to keep too small, uncomment the section and plan. So let's do that. And so you can see here the problem is, and it goes kind of side by side. We have two services here declared, but the job plan, Nomad is telling that it's going to update the service in place, meaning there'll only be one service at the end, where in reality, we have two services defined. So that's the bug. And following the user steps, I was able to reproduce it very easily. So that's big points for Apollo here. So now the thing is, Nomad does
Luis,
allow.
can we zoom in a little bit on the browser?
Oh, sure.
No problem.
So here it is. Is it good now?
Yeah, that looks good to me.
Cool, thank you. So we were able to reproduce the issue. That's great. And now to kind of like understand what's going on, the user was also very nice and provided a PR fix for this issue. And, kind of, we would do the same thing, but testing from their branch here. That's like the branch that was open for the PR. But when looking over the code, so let me open the, oh, that will look bad. So this was the code change for the PR. And actually, let me try to explain the issue that happened first. That might make more sense. So the problem is that this function here in Nomad is responsible for computing the diff between a list of services. So just like in the job spec, you have a list of services. One is your old services, the other is your new services. But the problem is that what Nomad is doing is it's creating a map based on the name. So it's using the name service to kind of identify each service. And the problem is that services can have the same name. In fact, that's one way that you can have on console the same service for different ports, is that you create multiple service blocks, both using different ports. So name is not unique. So that's why when he added a new service with the same name, Nomad was not able to compute the diff properly. So that was the problem. And now looking at the fix, what they did was they used the port label instead of the name as like the way to identify. And then they created another diff based on the name. So it's sort of like a two-level diff. So first diff on port labels. If there are more than one at the same port, then you diff on the name. So it's kind of like a tier diff approach, a two-step diff, you may say, which works fine. Like if we run this code, it will kind of do its job. But when reviewing this code, it was kind of, to me, pop up this idea of like having this two-stage diff. It's kind of weird because you already have all the information that you have. Now, looking deeper into the problem, we have an issue that there's no real answer. Like the more you start to think about this problem, you realize that there's no right answer. And to kind of explain why, let me try to draw something. And let's see, let's see how that will go. So imagine that you have, three services. So I'm going to just use colors just to like represent different services. So this is your list of services right now. So that's your old list. Now your new list looks like this. So that's your new list. So what happened between your old and new? Like that's what Nomad says. He only says the old list and the new list. Well, some people might say, well, this one went here and this one went here. So nothing actually changed. So this is like no diff. But, other people might, other people might look at this and say, no, what actually happened was that instead of the position changing, the color of these two services changed. So this went from green to pink, this went from pink to green. So there is a diff. There's or two diffs to be more precise, because you changed the color. So what's the right answer? Well, there is no right answer. Like those two are valid assumptions, because if you apply the diff, it will end up in the same result. Now, how would you solve the problem? You need some sort of identifier, some sort of unique and stable identifier. What I mean by unique is that each service, so if I go here and call this 1, 2, and 3, and I say this is 1, 2, and 3, well, now we see that this assumption is wrong because 2 changed color and 3 changed color. So this is the right answer. So the only way for us to actually know the solution is if we have this sort of ID that keeps stable. And what I mean by stable is that the same ID on the old list is represented in the new list. You might want to think of something like, oh, let's just hash the service and that's our ID. But the problem is that if the service changed, which was this case, the hash would change. And now we have 4 here, for example. So now the ID changed between old and new. So that's the only way we can find a proper solution. But we don't have that in the service block in Nomad because all of the fields in the service can be changed arbitrarily. So long story short, there is no answer. What do we do then? So when reviewing the code, I thought of having, like normally when you have the situations where there's no right answer, you just have like the best guess approach. And normally what that is done through like computing some sort of score. So that's what I suggested back. And let's look at like the final code review diff. So instead of trying to map a property of the service, what we do here is that we try to find a match. So let me find the part of the code here. So for each of the old services, we try to match on the new list of services. So going back to my drawing here, so for each of the old, we have a function that computes a score based on the old, and for each of the new gets a score. And then we just find the best score and say, okay, this service here became this one based on this score. And how do you compute the score? Well, that's sort of arbitrary. We end up like, I went up going back and forth with the PR author on like how to best, like which properties to look for, how much importance to give. We end up using 3 signals. Oh, so that's like a long explanation of what I just talked about. But we end up using 3 signals here. So first is the index. So think about those circles. It's like the position of the circle on the new list versus the old list. So that will give you a weight 1, and then the port label, and then the service name. Using those properties, we compute a score if they match. And then whatever is like the highest score, we say that's the match on the other side. So that's how we compute the diff now. Since there's no right answer, we just try to find a good enough answer. So that's normally how you deal with like uncertainties like that when you have an engineering problem and you don't have a right answer. So you need to have some sort of approximation or some sort of threshold, which is exactly like this part. It's like how much, how related these 2 services need to be. And we end up going with a threshold of 2 because it looked nice. Like there's no scientific reason why this is 2. We just tried different values, and this gave like the most natural diff results. So yeah, so that's like a fairly simple issue, easy to reproduce, easy to see why the problem. But the more you think about it, the harder and more complicated it gets. And in the end, like when you find out, it's like, oh, there's no actual answer. So now you need to approximate and think of like all these different things that need to go through. Yes, I think that's it for this issue.
I think in computer science, we call those heuristics, as in we took a best guess and we're calling it something fancy.
I personally prefer guesstimates, but this works for me.
Yeah, it's just hard. Like there's no right answer. So you need to guesstimate a nice heuristic. And like, I think if you put enough if else, you may be able to call it machine learning at some point, but I don't know where that threshold is.
So I just wanted to point out, I love your live drawings, your live explanations. They're great. Just, yes.
This is why we call him Professor Luis.
Oh, it's terrible. But this, actually, this like the drawing, this exact same issue happens in other areas of computing. Like I took this drawing from a Twitter thread from a React developer. So if you're a front-end developer, you might be familiar with this problem, because every time when you're doing like front-end stuff and you need to like render a list, for example, like a table, normally those JavaScript libraries, they require you to pass in a value because they don't know how to do this stuff. If you don't tell the library, oh, this is row number 1, this is row number 2, if the user like sorts the table, for example, that order will change and the library won't know which one is which. So that's why there's usually like a key parameter that you need to pass when you're like rendering lists and stuff like that. So it's a very common problem. Do you want to go to the next one? Is there any questions?
I don't think we've had any questions come up, but this serves as a good time to remind that if you're in chat and you have something you'd like to ask about the things we're talking about today with one of our engineers, please drop them in and I'll be asking them. By the things we're talking about was more hand wavy than I meant it to be, but you know, about kind of GitHub triaging and the issues that we're talking about, or tips for contributing or things like that. Yeah. I think that puts us in a good spot to go on to the next one, unless there's something James or Jasmine would like to share.
And I can't follow that. I love those explanations and that. It's great. It's awesome. I guess I will try and show this one issue that I wanted to talk about, and I haven't prepared anything like that, so viewers, sorry. Let me just find the right browser. I think it's that one. I'm hoping everyone can see. This one,
I think you just zoom in a tiny bit. Sorry. Yeah,
better?
there we go.
Cool. This one's kind of an interesting one because from what I investigated, it isn't actually Nomad causing the problem. So specifically, this relates to CNI, the container networking interface. So Nomad uses that under the hood to do some kind of fancy networking for your Docker containers or your network namespaces. And the reason I like this is because initially I was actually on triage when I took this. And also I'm trying to upskill in the networking area. So it was perfect timing, but the actual detail in the issue is for me really kind of exactly what I would want. Because it matches that kind of like, here's all the information, but it's not too overly verbose. And it was really easy to reproduce and figure out the problem. So specifically, they detail the kind of CNI, the client information, so I can, you know, put that in my config and run that. They include the actual CNI network information. So again, I can copy that, put it in my config, and I had to pull a few things out, but they're more than close enough, you know, exactly reproduce their problem. And then kind of, I'm not sure if assumptions are the right words, but, you know, detail what they're expecting to happen so that, you know, maybe I think Louise mentioned, I don't know if Louise mentioned it, but it was definitely in his documents for the initial tips. Like sometimes things work in a way because it's the way we designed it, or there's some restrictions that we're not sure about. And so having that information available is super useful. Sorry, my dog just ran in. And then even like the most slimmed down job file to try and reproduce things, that was really, really useful. And then even the logs. So I had kind of everything to go through, exactly what I was looking for. It turns out that it's not actually Nomad, but I just like this issue and I like the way it was written because it was very easy for me to follow in an area that I'm not particularly familiar with, or I wasn't at least 2 weeks ago. And it was great. And so, you know, I managed to respond, say it's not Nomad's fault, I don't think, but we'll keep investigating because, you know, it took a bit of time to figure out. and they were super happy with it. But the investigation was made super easy by the amount of information and the carefully crafted job spec and that they included. Yeah, that was my one I wanted to talk about. I just really liked it. So thank you to this person. No fancy drawings. And probably that will even say, like, if you're not sure where the problem is, don't worry about raising the issue. Like, it's very useful for us to understand if there are bugs in dependencies that we use. Because that means that if a customer runs up against it, another user runs up against it, we know the information, we can go and easily tell them and easily be able to respond.
And I'm not saying that all of our problems are the fault of other software. Sometimes it happens, but I can think of a few instances like where Docker changed some signal or like the default signal, and then we were using the wrong one. So we do use a lot of software and need to make sure that our software is kept up to date with that. So file away on tickets.
Yeah, there's like a lot of moving pieces. I know, just trying to kind of learn, like trying to write tutorials for like different things that we have. There's just so many. It's really cool to watch, but I can't imagine trying to keep up to date with everything. Like,
such is the nature of software.
Exactly. Yeah. Do we want to move on to the next issue?
Sure. So changing a little bit, the next issue is going to be from the Nomad autoscaler. So let me open the issue here. So this is the issue. So this is an interesting one because it's one of those scenarios where there's no reproduction steps. So if you look at the issue, it was very well reported. So there are lots of logs and ATL job files. But the problem is that this issue happens sporadically, and I tried a lot to reproduce it, but it did not work. I couldn't get the issue to happen. So, first explaining what the issue is, that's what I should get started with, but I forgot. The issue is that the Nomad autoscaler would just stop working. Like, it wouldn't crash, but it would just hang and not do anything. So, the user was very nice to even show like CPU usage and show that there's actually like nothing going on for a long time. And no matter how long they waited, the autoscaler would not come back. So the thing that I like about this issue is that it goes deep into like how Go works. Like, that's the language that we use. And just sort of like the things you need to keep in mind when you're doing distributed system work. So that's what I'm going to try to cover here. So look at the issue. That's the first gist here. It has the job file that they're using to run the autoscaler, which is very helpful because you can see all the like options and things that the user has enabled on their environment. Very helpful. But unfortunately, just looking, there's like nothing out of the ordinary here. So for this particular issue, it was not relevant, but always good to offer. Kind of like what James mentioned, being more verbose is always better. And the other thing that's very useful is just logs. So this is the autoscaler log output. You can see a lot of stuff happening, and then at the end, it just stops. And the user reported that there's no log lines after this. So it just like didn't do anything. So the first thing that I tried to do is just reproduce it the way I showed the previous issue. They provide us which version of the autoscaler they're using, always helpful as well. And then I tried to reproduce, didn't work. So eventually I asked them to stop their autoscaler using this ABRT signal here. For those of you who are not familiar with Go, if you have a Go process and you send this signal, Go will shut down the process and also dump the stack trace. So I asked them to do it. another a user. So that's what I mentioned, like if you're trying to contribute, like just looking at the issues and trying to confirm that it happens to you as well. Always very nice, because now I know that it was not specific to this user environment, it's something more widespread. But eventually they were able to get the signal in, and I think, yeah, so this is what happens. So you're going to see a lot of similarly random lines if you're not familiar with how this all look like. But from a developer perspective, this is super useful because it tells us exactly which Go routine are on the code. So it gives you the exact code line that your Go routine is at the moment the signal gets received. The problem is that on distributed systems, there are a lot of Go routines. So that's the log file that we need to parse. And yeah, I will explain the details of this log soon. But first, let's explain how the autoscaler works, because that's kind of relevant to like all the sorts of problems. So let's do another drawing. It doesn't like bad drawings. So the autoscaler it's like a process in an infinite loop. So you have the autoscaler running like forever. So this is like always doing a loop of actions. So the first thing that it does is it talks to Nomad to get, and this I'm talking about job scaling specifically because that's what the specific issue was about. So this is like you're changing your group count. So not from 0, from like 1 to 2, for example. So that's like job scaling. So what the autoscaler will do is it will use the Nomad plugin to talk to Nomad and retrieve information about your job policy or your scaling policy. And then you will send that to the autoscaler for the autoscaler to process. So this is also happening in a loop. So every once in a while, the Nomad plugin will talk to Nomad to retrieve the job policy. And then when the autoscaler needs to detect if it needs to scale or not, you would talk to the plugin to fetch that information. So this is supposed to happen in a loop, but it was not happening anymore. That's why the autoscaler was getting stuck. So the autoscaler process itself was still working, but the problem is that the plugin was stuck. And then since the plugin was not sending the autoscaler policies to be evaluated, the autoscaler was just doing nothing because there's nothing to do. Okay, so that's sort of how the autoscaler works, and that's kind of what the problem was. The way to parse this file here, it's kind of hard to see here, but normally we want to look for like this Go routine keys. So if I search for Go routine, you're going to see a bunch of them, and they have a specific ID to them. So that's also very helpful. And this is like, it's the type of action that is being done inside the Go routine and for how long that action is happening. So normally when I have a problem like this where something is stuck, I normally look for like select blocks. So a select is a moment where your Go program is going to stop and wait for something to happen. So that's one of the reasons why they're important. This one is not important. It's just about metrics, so it's not relevant to here. Other ones are sleep. So this means the Go routine hit a sleep command and is just waiting for something for that sleep to end. Also, usually not a problem. For us, the problem is normally this. So semi-acquire is your Go routine is stuck waiting for a semaphore. So semaphores are a way to control access to code blocks that are not supposed to be accessed in parallel. So going back to the drawing, like imagine if you have several instructions on your code, but like these two lines cannot be done in parallel. So what you do here is that you put a semaphore, sometimes called a mutex here, and says, first, acquire this mutex. So get a hold of this, do your work, and then here you release. So now this piece of code or this block of code, sometimes called the hot path or the exclusion zone, I forget how it's called. But this piece of code is only going to be accessed once in parallel. So if you have another process that is executing the same code, you will not be able to hold this mutex, this lock, because another Go routine or another background process is already holding it. So when I look at the code, and then you see a bunch of this happening everywhere. So that was basically the problem. There was a semaphore that is trying to be acquired, but it was being held by a different process. So now looking at the code, as I mentioned, when you do this tech dump, it tells you exactly the line of code that was being executed. These are not usually important because there's the Go source code. If Go has a bug, that's a bigger problem. So normally I try to look at our own code first. And this is the first line where this happens. So inside the Nomad plugin on line 170. So let's open that. Plugin on line 170. And oops, not plugin. The target plugin. So, oh, and I'm in the wrong branch, sorry. So here's the line. And you can see that it's trying to acquire this lock. Let's bump the font a little bit. So it's trying to acquire this lock. So it's waiting for another Go routine to release the lock. So all of the different things that are running in the loop are stuck here because another Go routine has this lock and is not releasing it, right? So that's a problem. When looking at the code, I need to see where the lock gets released. So that happens kind of in the next line, but it has a defer statement. A defer means this code will run when the function returns. So whenever the function here, which is the status, so it's trying to get the status of your job. So whenever this function returns, the lock will be released, but only if the function returns. So now the next step here when like debugging this is like, what could cause this to not be released? I think it's fair to assume that defer will always run because that's like Go by definition, it should run. So it means that the function is not returning. And then looking at the other lines, it doesn't do much. So it updates the map here. And that's why we need the lock here, is to like, we don't want to modify this map concurrently because then you can have multiple Go routines attaching to the same ID here. But then when you get to here, we start a background process. So when you call Go function, Go is going to run that in the background. And that's what's called a Go routine. So this function is running in the background. And now it's waiting for this signal here. So this arrow thing here is just a way for you to tell Go to like stop and wait for something to be received on this channel. So channels are a way for you to send information between Go routines. And the problem here is that if nothing sends stuff on this channel, this code will never move on. So it's waiting for the code. So channels are a way to synchronize process across Go routines. So, you know, that's our problem. And if we look back to the stack trace, So this is the file that is kind of the issue. So if you look for other places where the file is hanging, oops, not this one. So this one is just saying that the file created another Go routine. So this created by, I usually fine to ignore. But eventually, somewhere here, we will see, oops, I think I passed. Yeah, so this one is on line 182. So now we see that there's another Go routine, so different ID, that is blocked on a channel. So now this is like, oh, so it means that this Go routine is holding the lock and it's waiting on the channel. So if you go there, line 182, oh, that's exactly where we are. So it's waiting on the channel. Now the next step is like, okay, so I have a Go routine that's blocked here. So this unlock never gets executed. So all the other Go routines are blocked because they will never be able to go through here. Cool. Now, where this channel is being used, so this is used to notify that the first, to notify that the job policy was fetched the first time. And then if you look at who sends data on this channel, is right here. So you have a Boolean being sent to the channel inside this function here, and this function is being called here. So once this JSH object, which is the job handler, gets initialized, it will run this function, and this function will notify and unblock the other Go routine. So cool, and you can see it's a different file. So now if you go back to our stack trace, and oops, it's in the background. I forgot the file name, so plugin state. So now if you look for plugin state, you can see that there's a Go routine here that is blocked exactly there on line 136. So if you look at line 136, so the Go routine was doing this loop. So we have an infinite loop here. There's no exit condition, and it's fetching the status of your job. And if there are no errors, you'll keep going. But the problem is that if there are errors, it will just continue. Actually, here, it will just continue. So that was the problem. Like this loop was always like this and will never hit the line that we want, which is right here. So the loop will get here, go back to the beginning until there was no error. So that's kind of like how we navigated through that messy stack trace to actual code. And to understand what was causing the problem. So looking at the stack trace, finding those blocking points and where they map in the code, we're able to find where the problem was, and then just quickly going over the fix. So there are two changes. So first one is putting a timeout around that channel. So instead of waiting forever for this channel to respond, we have a timeout. If they don't respond, we exit, so the lock is released and the other Go routines can keep going. And then the other change was to move, yeah. So now we move the sorry, yeah. So now we move the check to like close the channel and unblock other stuff, even if there is an error. So we don't loop if there's an error. Like even with an error, we unblock the coroutine and keep going. So that's just like to show the amount of work that there is when working like distributed system, these type of things. It's sometimes very hard to debug, but hopefully we like looking at the right places, you can kind of figure out what the problem was.
That was really cool. Thank you for kind of walking us through that. I haven't even seen that side of things. That was like really neat to see. I do think we are at time, so we will not do issue number 1 today, which is fine because we could probably do an entire office hours just on that issue and all of the things that kind of come out of it and things we've learned. I guess just as we're wrapping, is there anything that you'd like to share to our audience or viewers? We'll kind of roundtable this one. We can start with James. Just like any like parting words or things you'd like to share.
You're all awesome. Thank you.
I'm going to point to Louise next then.
Yeah, just echo James. Thank you for trying Nomad. Thank you for submitting those issues. And yeah, just keep finding those issues away, and hopefully we'll get to them and have a proper fix.
And Jasmine.
Likewise. Yeah, likewise, everyone that's here today in the chat, and everyone that watches this video in the future, thank you so much. Please join our community. We're in the Hangouts Slack as well, in the Nomad channel. And we're on the Discuss forum. Please post your questions there, get involved, file tickets, and we'll see you around.
And I think just the +1 on the Discuss forum too, if there's things you'd like to see us discuss on community office hours in the future, please drop those in. Feel free to @ me. I would love to hear what you're interested in hearing more from us about. And that helps us to kind of put things together and bring stuff to you that you'd like to see. But with that said, thank you so much everyone for joining us today. And I hope you have a great rest of your week. Thanks. Bye.